Programmable Logic Controllers. PLC. Programmable Logic Controllers, or PLCs, that coordinate the real-time control functions in manufacturing operations. To describe manufacturing as a process, state how automated process control benefits manufacturing, and list full components of the Programmable Logic Controller, or PLC system. Let's start with understanding what is a process. A process is a series of tasks that take certain inputs and generates intended output. For example, manufacturing process is a process that takes input, such as operators, equipment, and material, and generate manufactured product as an output. In order to understand an important term, compliance, related to the process, let us consider an illustrative example of cruise control of a car. You use the cruise control mode in your car to set it to a speed so that you stay within the legal speed limit for a given road condition. Suddenly, the road conditions change, for example, due to ongoing construction in a segment of the road, due to which the legal speed limit reduces. What was legal speed before road conditions changed ceases to be legal now. In this setting, driver goes from compliant mode to non-compliant mode because of the changes in input, that is, the road conditions. Output of a process can be compliant if it meets predetermined specification, or they can be non-compliant if the output does not meet predetermined specifications. Based on whether or not a process is capable of generating a compliant output, a process can be considered to be in control if the process is capable of generating a compliant output, and out of control if a process is not capable of generating a compliant output. Processes cannot be expected to stay within control over time without any intervention. The process could start off in control, but could get out of control as time passes, if it is left alone. The main reason for processes going out of control is the change in quality of an input as time passes. In other words, in many processes, the quality of input deteriorates over time and this causes the process to get out of control. So how do we maintain the process output at a compliant level at all times, even when the process input changed? It can be done in 3 simple steps. Step 1. Obtain feedback from the actual output. Step 2. Measure the feedback obtained against what is acceptable, that is, predetermined specification for output. And Step 3. If feedback represents occurrence or potential variation from a specification, make changes to input, as needed. That initial is the concept of process control. Process control refers to techniques used to maintain a process within control at all times by using feedback from the output to make necessary adjustment to the process, to ensure our process remains capable of generating a compliant output at all times. In the car example, this could be humanized looking at the changed road conditions or looking at the changed posted speed limits, and using previously acquired knowledge to realize current speed is more than the legal limit and manually intervening to apply brake to reduce the speed to legal limits. This is referred to as closed-loop control system, which is different from open-loop control system, where the feedback from the output is not necessarily used. So systems are used in fast-paced software that are hallmark of distributed manufacturing enterprise network. As discussed in the previous, closed-loop control system rely on 3 main things. 1. Obtaining feedback from process output. 2. Performing the necessary calculations to compare the actual output against specification to decide if there is a current or a potential deviation of the actual output from intended specification. And 3. If such a current division is present, decide on the changes to the input and execute the changes as planned to maintain process within control. The execution tasks need to operate under the following conditions. They have to be real-time. Otherwise, process that is suspected of going out of control cannot be brought back in control in timely fashion. Rugged environment. Industrial settings typically are represented by series of conditions such as dust, moisture, heat and cold. Space constraints. Limiting the use of excessive hardwired relays and timers. And multiple input-output arrangement. A typical process control system has to obtain feedback from several data points, and will need to provide output to several devices to actuate planned process changes. The execution task under such conditions necessitates the use of PLCs. In other words, PLCs are one of the solutions to satisfy the above condition and provide the functionality of a closed-loop process control system. Now, let us focus on the main components of a PLC system. First, Input arrangement. We obtain feedback from processed outputs. 2. Processors. They perform the necessary calculations to compare the actual output against specification to arrive at changes required to the inputs. 3. Output arrangement. They provide signals to external devices, such as robotic arms, that will be used to execute the changes as planned to maintain process within control. And finally, the power supply, which powers the overall PLC system. With a basic understanding of different PLC components, we are ready to define PLCs. A Programmable Logic Controller, or PLC, is a robust industrial computer that monitors input and output and makes a logic-based decision for automated processor machines. The output generated from need to be transformed into actual change in the process to keep the process in control. Sometimes, this could mean increasing the speed of a conveyor belt or decreasing the temperature of a furnace for a limited time. This is where industrial robotics play a critical role in the process control. Industrial reward receive the output from in terms of what changes are required to the process input to keep the process in control, and actually execute the required changes in an accurate manner and in a responsive fashion. By responsive, we mean executing the change without much. Industrial robots are capable of multiple tasks such as lifting heavy loads and changing position of devices with a high degree of resolution and accuracy. These robots are primarily automated to perform tasks without human intervention.
Wow,